Hey everyone, this video is a warm-up for your quiz, your second quiz in Unit 4. So let's go ahead and get started with these two problems. The first problem is a graph of f prime, and it gives us some critical points here, some x values that we want to consider. It's got a point, something going on at A, something going on at B, something going on at C. Same thing at 0, D, E, and F. So let's go ahead and graph this out. It looks like B has a bit of a minimum. And then at 0, there's a maximum, a relative maximum. It crosses through the x-axis at D, a minimum at F. And then it starts kind of high here at A. Something like that. You can look at the actual lesson to see what this graph really looks like, but that's a pretty reasonable estimation of the graph. And it says that this graph is the f prime graph. Now it's asking for when f is decreasing and concave down. When is f decreasing, and concave down. So let's just do some justification here. F decreases when f prime is negative. So this is all based on the little chart that we have here. So we know that the function of f, the graph of f, is decreasing when f prime is negative. And then it also wants to know when f is concave down. So we would say f is concave down when, and we can interpret this either through f prime or f double prime. So first thing I'm going to say is f is concave down when f double prime is negative. But then as a result of that, we can therefore say when f prime is decreasing. Okay, again, that's the relationship of our f prime, f double prime chart. It helps us understand things in a very in-depth way. So make sure you get a hold of that. Make sure you understand that, and you can see that off to the side over here. So we are looking for when f is decreasing and concave down all at the same time. Since we're looking at the f prime graph, we need to be interpreting our answer in light of f prime. So we're going to say that we are looking for when f prime is negative, and decreasing. That will give us our answer here. If f prime is negative, that means f is decreasing. And if f prime is decreasing, that means f double prime is negative, which implies f is concave down. So within this interval, f prime is negative. Given this f prime graph, f prime is negative when it's below the x-axis, and it's decreasing anywhere it's going downhill. So first we're going to narrow our scope to just looking below the x-axis. We can see that it's decreasing within that interval from D to E. So we would say from D is less than X is less than E. And that is our final answer for number 1. Okay. For number 2, in the warm-up, we're given a function. Now this function is f prime. So it says that f prime of x, for number 2, it says f prime of x is equal to negative x cubed e to the x. And we're looking for when f is increasing and concave down. Well, it's pretty easy to see when f is increasing because we're looking at the f prime graph. So I'm going to go ahead and write this down here. F is increasing when f prime is positive. So that's the first part we're going to note. We're looking for when f prime is positive. So since we have the f prime function, we're going to go ahead and figure out when that's positive. And the first step in figuring out when f prime is positive is to set f prime equal to 0. So we'd say 0 equals negative x cubed times, and I'll put times e to the x here. That's given there. And then the solutions for this are when x equals 0. And the reason that's true is because we have a product of two things. When the product of two things equals 0, that means either the first term has to equal 0 or the second term has to equal 0. Well, the first term equals 0 when x equals 0. The second term, since it's exponential, it never equals 0. Exponential function has a horizontal asymptote of y equals 0, and so therefore it never goes below the x-axis. It's always positive. There is no zeros for that. So here's where we have 0 for f prime. So from here, we're going to go ahead and set up a number line for f prime. So we know that f prime of x is 0 when x equals 0. And then we have to check our signs on either side of that. So we're going to plug in a negative number to this side of 0. If I plug in negative into my derivative graph, or into my derivative function, a negative cubed is a negative, times a negative is a positive. And if I plug in a negative here, e to the negative power is still a positive value. So anything where x is a negative number will produce a derivative that is positive. Now if I plug in a positive value for x cubed would then be positive, times the negative is a negative, and then e to the x is positive. So a negative times a positive is a negative. So we can see that f is increasing when f prime is positive. So f is increasing from negative infinity to 0. Now the second part of this is to figure out when f is concave down. So let me go ahead and justify that here. F is concave down when, well, we have two ways of looking at when f is concave down. If we're looking at the f prime graph, we can see that f is concave down when f prime is decreasing. You can see that in the chart. The problem is we can't observe when a function is increasing or decreasing just by looking at the function itself. You have to get to a place where you're dealing with positive and negative values. So f is concave down when f double prime is negative. Okay? So we have to get to the f double prime graph. So we're given f prime here. We're going to go ahead and take the derivative of this. So f double prime of x is equal to, and since this is a product here, we're going to go ahead and apply the product rule. So the derivative of the, let me go ahead and highlight these pieces so we can see them a little bit easier. The first function is negative x cubed, and the second function is e to the x. So now the derivative of negative x cubed is going to be negative 3x squared, then times the second part, so times e to the x, plus the derivative of the second part, which is e to the x, times the first part, which is negative x cubed. Okay, so I'm going to go ahead and clean that up a little bit. First, I'm going to go ahead and factor. And I notice in both of these terms, I have a negative that I can factor out. I have an x squared that I can factor out, and I have an e to the x that I can factor out. So this is going to say negative x squared times e to the x, and then times, we have a 3 left over here, and a positive x left over there. So there's my f double prime function, and it's already factored for us. We're looking for when f double prime is negative. Well, then we have to set f double prime equal to 0. So 0 equals negative x squared times e to the x times 3 plus x. And this function is equal to 0 either when this term is 0, this term is 0, or this term is 0. And so we could say that happens when x equals 0 for this guy. E to the x is never 0, so we don't have to worry about that one. And then when x is negative 3, we also know f double prime is 0. I need to take a step back real fast because I forgot to mention, when you're talking about identifying your critical points are when the derivative is equal to 0, like we did here, or when the derivative does not exist, or at endpoints. There were no endpoints to this function, so we forgot to mention that we also have to look for when f prime does not exist. Well, in this function, f prime always exists, so therefore there are no other critical points other than when x equals 0. But I do want to mention that. I want to mention that there is a critical point. I want to list the critical points, so that's when x equals 0 there. If I had a place where f prime does not exist, then I would also want to list those points as critical points and check to see if there's any sign changes around those points as well. So just be careful with that. And the reason we don't have a point where f prime does not exist is because we're not dividing by 0 or taking the square root of a negative number. Same thing down here. The next step would be to check to see where f double prime does not exist. Again, no matter what x value I plug in here, f double prime will always exist. So therefore, we would mention that our critical points are only when x equals -3 and 0. Okay? So now we're going to set up our number line, but this time it is for f double prime. And we have a critical point, we would say. Not an actual critical point because we're talking about f double prime here, but we have a point that is critical or a point of interest when x equals -3 and when x equals 0. So now we're going to check our signs on either side of those intervals there. And so if I plug in a -4, if I plug in -4 here, -4 squared is a positive times a negative here. So we have a negative times a positive times, this is always positive. If I plug in a -4 here, this is going to become a negative. So negative times a positive times a positive times a negative. That's going to end up being positive there. The next part is in between -3 and 0. So if I plug in a -3, I get a positive there. And, sorry, if I plug in a -2, I get a positive there, a positive there, and a positive there, and then a negative out front. So that's going to be a negative there. And then the last part is greater than 0. So we'll plug in any positive value. X squared is positive, e to the x is positive. If I plug in a positive number there, I get a positive. So a negative times a positive times a positive times a positive is still negative. And the reason, one way to see that we don't have a sign change on at x equals 0 is because the 0 is produced by this function right here, this part of the function right here, the x squared, and x squared doesn't is always positive, so there can't be a sign change there. But besides that, now we know when f double prime is positive and negative. Now let's go ahead and look for what we actually want. We want to know when f is increasing and concave down. So we would say f is increasing and concave down, if I could spell here, and concave down when f prime is negative and f is increasing when f prime is positive and f double prime is negative. Okay, so that's what we're looking for here. First thing we need to look for is when f prime is positive. Well, we see that f prime is positive for all negative x values. So within that interval, now we're looking for when f double prime is negative. So for all negative x values, we see that f double prime is negative from -3 to 0. So our final answer is going to be -3 is less than x is less than 0. And again, the reason for that is because this is the only interval from -3 to 0 where f prime is positive and f double prime is negative. So that's the warm-up for today. Hopefully that helped prepare you for your second quiz in this unit. So I'll see you again next time.